great example of the use of regression is an attempt in Chance magazine 1995 by Ashenfelter, Ashmore, and Lalonde to predict the price of Bordeaux wine for each year of vintage. Bordeaux wine is from France. It's supposed to be about the best wine there is, based on objective weather variables that can be measured. And most people in the wine business think you just can't do this. Okay, in other words, you have to be an expert on wine to figure out if it's going to be a good wine vintage or not. But this article and this research shows that that's just not true. So what we have is our dependent variable. We take the logarithm of the price of the vintages from 1952 to 1980. That's what we're trying to predict. Okay, now 1961 is considered sort of an average price index, and so basically we're looking at, for 1952 for instance, the price of the vintage 1952 compared to 1961. We take the logarithm of that. That's why these numbers are not really big or really small. And the reason we take the logarithm is something called heteroscedasticity. In other words, the accuracy of our forecast can depend on what the value of what we're trying to predict. And in that case, you should take logarithms, or else the assumptions of regression that are used for hypothesis tests are not valid. Perhaps we'll do a video on heteroscedasticity in the future. Okay, so that's what we're trying to predict. Okay, and there are basically three weather variables that really seem to matter. Basically, if you have a dry, warm summer, okay, and you have a lot of rain in the winter, you've got a really great wine. Otherwise, you don't. And so what we do is use these four columns as our independent variables to predict that logarithm. Okay, so this is basically W rain would be the winter rain. Okay, this is the average temperature in the summer, and this would be the summer rain. Okay, and so basically, and then this is the age of the wine. In other words, we're looking at the price index as measured in 1983. So 1952 was 31 years before that. So basically, the older the wine, it's going to have some sort of value. So we'd run a regression with basically this column being the dependent, these columns being the independent. So we'd go to data analysis, regression. Okay, you can see we use P6 through P33 as Y. Okay, columns Q through T is X, and then we threw the regression output down here. So let's take a look at it. And it's pretty good. We got an R squared of 83%. Okay, the standard error is 0.28. Hard to interpret when we're dealing with logarithms. But the coefficients have exactly the right sign here. So there's our intercept. But basically, we see a positive coefficient. All these p-values are significant. 0.02, 1 in a million, 9 in 100,000, and then the age of the vintage, 3 in 1,000. So all those p-values are terrific. Okay, you wouldn't want to throw any of those variables out. And the authors looked for other variables that they could throw in to try and improve the goodness of fit, and they couldn't really find any. Okay, so this coefficient is positive. So if it rains a lot in the winter, you're going to have a higher price of the wine. Okay, if it's hotter in the summer, this is the most important variable by the p-value, then basically it's going to have a higher price of the wine. And if you've got H rain, again, was the rain in the summer, more of that means you're going to have a worse price for the wine. In other words, if you drench the vineyard, that makes sense, the wine is not going to be that good. And of course, the older the vintage, the higher the price of the wine. So everything works out pretty well. And these independent variables turn out to be fairly uncorrelated. Okay, now if you go data analysis, correlation, okay, we use the three weather independent variables, and then we put the right correlations right here, and we find that basically winter rain and temperature have a slightly negative correlation. Summer rain and winter rain have a slightly negative correlation. And interestingly enough, temperature and summer rain are basically uncorrelated. So we don't have probably any instance of multicollinearity here because these independent variables don't exhibit strong correlation or a strong linear relationship. So basically, this is a pretty good regression, and it does show that basically you can use quantitative methods to pretty well predict it's going to be a banner year for Bordeaux wine, when in the past people thought you had to be a wine expert to do that.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of three books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytic stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so, yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.